Microsoft research has always been good, but lately, for the last few weeks, they have been quite active, and one after another, they are releasing some phenomenal papers. This paper, Direct Nash Optimization or DNO, is one of them, in my humble opinion. In this paper, they have achieved dual goals of post training LLMs against a more general class of preference models while providing a practical and scalable implementation with finite sample analysis. Their strong empirical results are based on the insights that optimizing general preference functions can be reduced to finding the Nash equilibrium of a two-player game with a payoff as a preference, and further solved by a single play algorithm. Most techniques to optimize for this objective use soft policy iteration, which is difficult to implement faithfully and may require unstable on policy and two timescale updates. But this direct Nash optimization addresses these challenges by approximating soft policy iteration updates with a regression based contrastive objective in a batched manner, which is a much more stable and forgiving learning objective. Now, this new DNO from Microsoft already has beaten direct preference optimization by applying game theory to LLM reinforcement learning. And as I said earlier, that it doesn't even require a reward model. So, this Nash equilibrium is a game theory concept in which each participant's choice is considered optimal given the choices of others. Essentially, no participation can gain by unilaterally changing strategies. As applied to LLM alignment, the Nash equilibria is the point at which model responses to variate prompts on average most aligned to preferences. Improving any single response would cause others to move out of distribution. Direct Nash optimization finds the overall Nash equilibria as opposed to reward maximization on individual response pairs like DPO, allowing the model to understand the complex interrelated preferences while avoiding the DPO whack-a-mole situation with alignment on one pair negatively impacting others. The implementation detail, which is presented in this paper, is quite interesting, and I will drop the link to it in video's description. According to it, they have used 7 billion Orca 2.5 base model, and then they prompted this model with questions from Ultra Feedback. Afterwards, they selected 5 model responses plus one extra gold standard from GPT-4. Then they used GPT-4 to rank 6 responses using specific criteria and then selected 2 of 6 responses to create a pairwise preference probabilities. Then objective loss function simultaneously considered batches of preferences pair seeking to optimize for the Nash equilibria, and then they updated the model and then repeated and rinse. So the resultant um, findings were really interesting. This process improved a model from 7% to 33% on alpaca eval 2. Also, or this new Orca 7 billion model uh, has already beaten Mistral Large plus GPT-4 on Alpaca Eval. How good is that? Also, it significantly improved Orca 7 billion versus DPO spin, and it allows for complex preference relations. The regression-based learning objective eliminates need for reward model, and bashed updates improves efficiency and stability of training. I'm more than sure that this research is going to be massive very, very soon because the field of AI is evolving towards advanced models that can understand, reason, follow complex instructions, and create nuanced content while aligning with human values and preferences. LLMs have demonstrated remarkable capabilities in generating human like text, answering questions, and coding, yet they still face challenges in tasks that require a high degree of reliability, safety, and ethical alignment. To address these challenges, fine tuning LLMs using RLHF has demonstrated that strong potential for making LLMs more helpful by aligning them with human values. But this direct Nash optimization just takes it to another level, as I just told you, that achieves the best of both models, combining the scalability of contrastive objects with the theoretical soundness of general preference optimization. DNO is designed as a bashed on policy algo with a regression based learning objective, and this design choice makes DNO stable and scalable, striking a balance between deployment efficiency and adaptability. So, all in all, great stuff. Theoretically, they have already proven the DNO converges to the intended Nash equilibrium on average, so which is in itself a great thing. So that's it, guys. Let me know what do you think. I hope that you like the content. If you do, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as that helps a lot. Thanks for watching.